interchange the
X
value.
and Y. Okay?
Yes, sir.
Final interchange X and Y. Okay. Now these all things you know. Okay, so for example, this one. Okay, you express X in terms of Y. Okay, this
Sir,
one.
I can't see your screen.
You can't see my screen. 1 second. Can you see now?
Yes, sir.
Okay. So for example, this function. This is a function. Okay.
Yeah.
Now you express this in terms of Y. Y equals to this. You express X in terms of Y. Then you just interchange X and Y. Okay.
Yes, sir.
Okay, so function, the one way of looking at the function is another way also, another right side. Here, what is the left side? Left side is R. It is defined like this. Okay, the left side is this minus this. Okay,
Hmm.
everything except this minus d by c. Why you are removing minus d by c? Because the denominator will become 0. That's why we are
Okay.
removing that. Okay, so function also, the another way of looking at function is there are two sets, okay, that is defined here. The function is defined from something to something. So for example, x to y. So that means there is a set x and there is a set y, and you are trying to map the elements from set x to set y. Okay, obviously
Okay.
all elements in x should get mapped. Okay, otherwise it's not a function.
Yes,
Okay,
sir.
okay, and some elements in y need not be mapped.
Okay.
Okay, because if all elements in y are also mapped, then that means it's a
Sir, I didn't get
all
that.
elements in y are also mapped. What does it mean? That means it's an onto function, right?
One to function.
Onto function, right? And and what is one? The number of elements in x, number of
Is it
elements in y, they are exactly mapped to each other. Then that is a one function.
one function?
One function. One f of x equals to f of x1 equals to f of x2. Then that implies x1 should be equal to x2. Okay.
X2.
Okay. Now we'll cover relations separately. Let's look at all the functions related thing.
Okay.
Okay, periodic functions, did we discuss? What is a periodic function?
No, sir. We stopped at inverse last time.
Okay, we stopped at inverse last time. Okay, so periodic functions, let me start with some trigonometric function. Okay,
Yes, sir.
like for example, sin x. Just give me a minute. Okay, this is sin x, right? You know, sin x repeats itself after every 2 pi units, right?
Your screen is still projecting the questions.
Oh, sorry. One second. Okay, can you see?
Yes, sir.
Okay, this graph actually repeats itself after every 2 pi units, right?
Yes, sir.
So that means if you take any f of x, okay, let's say f of 0.5, okay, and f of 2 pi plus 0.5, that is this one, right? F of x plus f of x plus something. In this case, f of x plus 2 pi is still the same, right?
Yes, sir.
F of x is this one, f of x plus 2 pi is this one, f of x plus 4 pi is this one, f of x minus 2 pi is this one, minus 4 pi is this one, like this. Agreed?
Yes.
Okay, so what does that mean? The graph is exactly every point in the graph is repeating itself after 2 pi units,
2 pi.
right? So basically, if you do it in normal trigonometric fashion, so you'll get the same thing, right? After 2 pi units, everything will fall in first quadrant. If
Yes, sir.
originally it was 30 degrees, after 2 pi units, again, it will fall here. After the 360 plus 30, again 720 plus 30, right?
Yes, sir.
Likewise, right? Similarly, if you go backwards also, then also it doesn't matter. The point, the angle will still fall here only. Agreed?
Yes, sir.
Right. So a periodic graph is this. F of x is equal to f of x plus some t. What is the t? That is some period. Okay.
Okay.
So now f of x equals to f of 2 pi, or f of x equals to f of x plus 4 pi, whatever. The t can be 2 pi, 4 pi, 6 pi, 8 pi, whatever, right? But the
Hmm.
minimum of all of that is 2 pi, right?
Yes, sir.
All others are multiples of this 2 pi's,
Yes, sir.
right? So that minimum thing is the period of the graph. Okay.
Okay.
If it is a periodic means, what is periodic? Periodic means it repeats itself. Okay.
After an interval of
Just like the
time.
English meaning of the word period. Okay.
Okay.
What is the period? Because it repeats itself. Every day you will have the same period, or
Yes,
uh,
yes.
whatever that happens cyclically, right? Like seasons
Yes.
are periodic, whatever. Okay.
Yes.
Similar meaning in periodic table also. Why is it called a periodic table?
Because it occurs at every interval.
Right. So because the properties of these elements, they repeat itself after a certain group or certain column, whatever. Okay. So
Yes.
that's why these are called periodic. So for example, now x minus, okay, what is this one? Fractional part of x.
Okay.
Okay, this function. So this is also periodic. Okay. Now can you tell me what is the period of this red graph, fractional part of x? What exactly we are doing? Tell me here.
To find the period of the graph.
Okay. What exactly is this graph? Why is it like this?
Rational part.
Fraction part. Because if you take any number like zero point 0.5 or 1.5 or 2.5, the value is still zero point 0.5 because we are removing the integer part of it. We are keeping only the fractional part of it, right?
Fractional. Yes, sir.
So 1.5 ideally would have been here. We are removing that one. 2.5 would have been here. We are removing that two. So that we are taking only the fractional parts. So that's
Hmm.
why it is periodic. Now what is the period?
Sir, in terms of pi?
No, no, no. It cannot be in terms of pi this time. Agreed.
Yes, sir.
Okay. So why it can? Okay. So the period is actually this point and this point. What is the difference? One, right?
One.
1 unit. This point and this point, 1 unit. This point and this point, 1 unit.
One
Okay.
unit.
So it cannot be in terms of pi. Okay.
Yes.
So now, so for example, sin x, and cos x, cos x is also periodic. Okay.
Yes.
Agreed. This is periodic. Now, if you join these two, for example, f plus h. Okay. You can see the bigger graph, right? That is
Yes.
also periodic. Agreed or not?
Yes, sir.
That is also periodic. Which one? This
F
one.
of
This one
x
is also
plus h.
periodic. This is also periodic. Just that instead of sin x would have started at 0, cos x at 1. So the sum is actually 1. And there is a peak. Where is this peak? At pi by 4.
Pi by
Okay.
4.
At pi by 4, and this has become 0 again. This has become 0 again. Again. So now this is interesting, right? This is periodic. And what is the period now again?
Again 2 pi.
Again, is it cos x is repeating it? 2 pi, sin x is repeating at 2 pi, but this graph actually it is 2 pi, just that it is repeating, this part is repeating.
Huh.
Okay, this part is repeating. Okay, it is
Yes.
still 2 pi. Okay, so now basically what does that mean? This one is at 2 pi, this one is at 2 pi. Obviously some will definitely repeat at
2
2
pi.
pi. Okay, so now, say for example, instead of sin x I will make it sin 2x. Okay, suddenly you are making it to repeat at pi.
Okay.
Okay, but this is still repeating at 2 pi. Now what is the period? Okay, I'll zoom out. Now see, where exactly is it repeating?
Pi by 2.
Is it repeating at pi by 2? You look at the graph. If you want, I will change this one to pi's. Okay, just look at where exactly is it repeating.
2 pi itself
It's
again.
still repeating at 2 pi, right?
Hmm.
This part, okay? This is still repeating at 2 pi. So basically, what does that mean? So for example, this fellow is completing a cycle in pi units,
Hmm.
okay? This fellow is completing a cycle in 2 pi units time. Obviously, both together will complete a cycle in 2 pi
2
units.
pi.
Agreed? Just like you would have in basic arithmetic in earlier classes, right?
Yes, sir.
People are running around the ground. One fellow is taking 3 rounds, another fellow is taking 4 rounds, whatever, whatever. When they will meet again at the beginning. This is
Yes.
the same problem. Okay? This fellow is taking 2 pi units to complete the cycle. This fellow is taking 1 pi
Right.
units to complete the cycle. When they will meet again,
Two.
obviously 2 pi units. What is this 2 pi? Basically the LCM of these two.
Okay.
Agreed? Now,
Yes.
this fellow is taking the pi by 3 units. Basically, he is taking pi by 3 units to finish the cycle. He is taking this is 2 pi by 3 and this is 2 pi by 2. Right? Now,
Yes.
basically, you take LCM of both the periods of these two. Okay? Agreed?
Yes, sir.
Okay, this is the what is the period of this? This is 2 pi by 2. Right?
Yes, sir.
This is 2 pi by 3. You take the LCM of these two and find out what is the period. Okay?
Yes, sir.
That is one part of it. Now, sometimes this LCM might also give a bigger number.
Okay.
Okay. In some special cases. Why? Because this is not exactly equal to that problem. That when do they meet again?
Okay.
Okay. So, for example, there is some sin x. There is uh, minus sin 2x. If you add these two, obviously you'll get 0. Right?
Yes, sir.
Okay, so because what I'm trying to say is addition is not exactly equivalent to when they will meet again. Okay, this is simplistic assumption that the LCM part I told you, right?
Yes,
That
sir.
is actually simplifying that thing, but it is not exactly equal to the this thing. Okay,
Hmm.
okay. So sometimes what you have to do, but that guarantees one thing. What is the guarantee? It will definitely repeat at the LCM, but there might be an earlier place where it can repeat also
Yes, sir.
depending on how you are joining both the functions.
Okay.
But one thing is guaranteed. What is guaranteed? That
The
at LCM
LCM.
they will definitely repeat. Okay, at LCM they will definitely repeat.
Yes.
But there might be a case where they might repeat little earlier also.
Earlier. Yes, sir.
Okay, but it is guaranteed that at LCM they will repeat.
Hmm.
Okay. Now, what you do generally by looking at the options, you can see that even if you can substitute the options, right, you can clearly see whether that is periodic. For example, okay. Now we'll go back to the question. This function, which is it is not periodic, he is saying. So basically, if you substitute x plus pi in this, if you are getting the same function, obviously it is it is periodic, right? For example,
Yes, sir.
sine square x or sine square x plus pi or cos square x plus pi, and whatever this one. Okay, understood. All of
Yes.
this will get satisfied only except this one. Two,
Okay.
if you replace x plus pi here, it will not be equal to tan of 2x plus 3, right?
So, sir, tan of 2x plus 3, is it
Hmm.
not periodic, or it is periodic but it does not occur at pi?
Okay, you tell me.
Sir?
You tell me. You tell me. You tell me, is it not periodic or the period is not this one?
Sir, I feel it is not periodic
Why it is not periodic?
because in the, sir, like f of x, in the x part, it is a bit complex. I don't know. I felt that it is different from the rest three, that's why I was.
Okay, okay. So tan of 2x plus 3, right?
Yes, sir.
Now what is this? What is this question?
They're saying which one does not fall under the period of pi.
Okay, just substitute this thing, no? The period of tan x is pi.
Okay.
Okay, so now forget about this 3.
Huh.
Okay, what is the period of tan 2 pi? 2 tan 2x?
Period of tan to
Tan 2x.
2 pi.
No, no, no. Tan x is pi. Tan 2x should be pi by 2, no?
Pi by 2.
Understood.
Yes,
Okay.
sir.
So tan 2x is periodic, right?
Yes, sir.
Okay, tan 2x you are adding something. Okay, every time you are adding something. So that also should be periodic, no?
Okay. Yes, sir.
Understood what I am trying to say.
Yes, sir.
Okay, see, for example, uh, tan, okay, there is some function f of x, and there is that function f of x plus a or x minus a. What does that do? It will just shift the function. Agreed?
Yes, sir.
It will just shift it horizontally left side or right side. But it
Yes.
will not change the nature of the function, right?
Okay.
Okay, agreed.
Understood.
What I am trying to say. This is a function. Okay. Now, uh, now if you are changing the function from if what you are doing, what is the transformation f of x plus a or f of x minus a, right?
Yes, sir.
X plus a or x minus a, what it will do? It will only shift the
Shift
function,
the graph.
shift the graph left or right. But if it is shifting, but it is not stretching or compressing, or it is not doing anything else.
Yes, sir.
Okay. When it is not doing anything else, if it is just shifting the graph, obviously if the original graph was repeating at some time, the later graph should also repeat at the same time.
Yes, sir.
Agreed. Agreed. So when you are shifting a graph, obviously the periodic nature of the graph should not be changing, right?
Yes, sir.
Agreed. What I am trying to say, because you are
Understood.
not doing anything, you are just shifting the graph.
Okay.
Okay. So that's why this one should remain periodic. But the thing here is tan x, the period is
Pi.
pi, right? But tan 2x, the period is actually
Pi by 2.
pi by 2, right? Now, this tan 2x, you are shifting left and right.
Mm.
So, the period is definitely not pi. Understood?
Okay. Understood,
Tan,
sir.
2, tan 2x, if at all the period should be pi by 2. Okay, ma?
So if it was tan of x plus 3, then it would have been the pi. Okay,
Tan
then.
of x plus 3, yes. Then it would have been pi.
Okay, understood.
Understood, no?
Yes, sir.
Okay. Can you see my screen? I am trying to draw.
No, sir.
Okay, wait.
Yes, sir.
See what it has happened? Tan x and tan x plus 3.
The graph just shifted.
It just shifted. That is supposed to be that, right? It is supposed to shift. The graph is supposed to shift 3 units. Uh, so which is the green one? Okay, so what I will do, tan x of, let's say I will do pi by 6. Understood?
Yes, sir.
So what is happening?
The
This
graph
is
is
this is
shifting
tan
by
x. This is tan x. And what it has shifted, the graph is shifted pi by 6 units towards the left. Agreed?
yeah. Yes.
Okay, it is supposed to shift likewise, right?
Yes, sir.
Okay, that's how that is happening. Okay.
Okay.
Okay, so this is periodic, that is also periodic. You are not changing the nature of the graph, you are just shifting the graph.
Okay.
Okay, now tan 2x, tan 2x, that should be, if it is tan x, then tan 2x will take two repetitions, tan x and tan 2x. Agreed?
Yes, sir.
Where is this tan 2x? Tan 2x, okay. One of them will coincide with the other one, okay?
Yes.
So, okay, this is tan 2x. So, this is completing, the cycle is completing within pi, right?
So that is
Oh,
tan x.
sorry, this is tan x, this is tan 2x, right. See, the cycle is completing at pi by 2.
Okay.
0, the difference is pi by 2, this difference is pi by 2, this difference is pi by 2, okay?
Yes, sir.
Okay, so now this And what is this one? This versus this. Okay, we are just compressed the graph.
Okay.
Agreed, no?
Yes, sir.
Okay, cool. So now we'll go back. Okay, so in this chapter, are there any questions that you are not able to do? You looked at these questions also, JEE questions.
No, sir. Yesterday I solved only KSET.
Okay, okay, case that you are able to do, no? Okay, so
Yes.
this, say for example, this one, odd function, even function, you can easily do, right?
Yes.
F of x, f of minus x. Okay, fine. Then let me see if there are any functions related questions. These are sets. We will cover sets again. Okay.
Yes, sir.
This one, domain and range, you can easily do, right?
Yes.
This one you can do. Uh, this one you can do, right? F of x is given, F inverse you have to calculate. You can do,
Yes,
right?
sir.
This you can do. Uh, this one you can do, right?
Hmm.
Range. This one, see, period. Period, what you will do? There's a cos square, there's a tan 4x. So cos square, you can turn it to cos 6x, then you are taking LCM. Okay?
Okay, sir.
LCM of this and this. You know, right? Cos 6x, what is it? 2 pi by 6. Here, 2
Yes.
pi by 4. Okay? Sorry, this is pi by 4.
4 by 4.
LCM. Pi by tan x is pi, tan 4x is pi by 4. You are
Hmm.
taking LCM. This you can do, right?
Yes, sir.
This you can do, right?
Yes, sir.
Uh, this one can you do? This one, is it 1 1 or on 2?
Yes, sir. Yes,
Okay,
sir.
so this is basics of inverse trigonometry functions. No,
Hmm.
this function is this, and because sine inverse x is 1 1 and on 2. Okay, this one should also be
100
1
on
1
2.
and on 2. Just that you need to be little careful about the domains and ranges, whether in that domain it is 1 1 and on 2 or not. Okay.
Okay.
Mm, so this one you can do, right?
Yes, sir.
3x plus 4. It's a straight line. A straight line is generally 1 1 and on 2. Okay.
On.
Now this one is taking only the right part. Okay, so that's what you have to see. Here also is taking only the right part. As long as you're taking only the right part, then most of the this is only this one is not onto. This one is clearly 1 1 onto. This one
Hmm.
is clearly 1 1 onto. Agreed, no? So
Yes, sir.
this one also this kind of problems. Okay,
Okay,
these
sir.
kind of problems you can do. If it is asking periodic, this is straight away periodic, right?
Yes, sir.
Okay, so which of the following is non-periodic? So see here. Is 1 if x is a rational number, is 0 if x is an irrational number.
Yes.
Okay, so it's actually little tricky, that requires little more understanding. Okay, so this one you leave it. Okay,
Okay, sir.
because we need to cover a little bit about how are rational and irrational numbers distributed. Okay,
Okay.
this one you can do, this one you can do. Okay, this we will revisit later. These kind of things you can do, right?
Yes, sir.
F of x you can do. Then domain and range, some set is given. This also you can do, right?
Yes, sir.
Okay, very good. So these are sets related. This you can do, right? This
Yes.
also you can do. So basically, these type of questions you can do. This one you can do, right?
Yes, sir.
Fraction part, distributes. These all things that you can do. Okay, good. Then I think we'll go to limits. Okay.
Limits. Okay, sir.
Okay. So the functions, at least because we don't have much time, if you want, we'll revisit this again later.
Okay.
Okay. Now let's go to limits. Okay. Now, firstly, tell me what is the limit?
Limit is basically constraining that value from a minimum to a maximum point.
Okay. So, what is the English meaning of limit? English word.
Up to a certain point, you can.
Something, some kind of boundary. Okay. So, this is limit means this is the boundary of something. Okay. Now, limits are actually very important. Okay. Let's take. And I'll give you two functions. Okay. Uh, I'll give you two functions. You should tell me what exactly is the difference between these two. Okay. First function is f of x equals to, let's say, some 2x from x plus 2. Okay. That is the straight line. Agreed?
X plus 2.
X plus 2 is a straight line, right?
Yes, sir.
Okay. Now, second function is x square minus 4 by x minus 2. Okay.
Okay.
So, are these two equal? That is the question. So, because if we factorize this, this becomes x minus 2 into x plus 2, and x minus 2 will get cancelled. This should become x plus 2. Agreed?
Yes, sir. Both will
Okay.
be equal.
Now both are equal or not is the question.
They are.
They are equal, but except one point. When x equals to 2, this suddenly becomes not defined. Okay, because the
Yes.
denominator becomes 0. But there
0.
is no problem here. Okay,
Yes, sir.
everywhere else these two are exactly equal, right?
Yes,
But
sir.
there is one point where this one just doesn't exist. Okay, this exists, right?
Yes, sir.
Everywhere else both are exactly same. Okay.
Okay.
Now, when we say, when we want to say, we would ideally want to say that this is also defined at x equal to. We want to discuss how it behaves at x equals to 2, right?
Okay.
We cannot clearly say f of, let's say this call this function is g of x, g of 2 is 2. We cannot claim, right?
Mm. Yes, yes.
So, but instead of, because we cannot claim that, what we do, when limit extends to 2, g of 2 is actually 2 is what you will say. Okay.
Yeah.
Okay, the point here is actually we are getting as close to 2 as possible here. Okay,
Okay.
but we are not exactly touching 2. Okay, sorry, we are not, we are getting as close to 2 plus 2, 4 here also. Just that if you want 4 from this expression, you cannot get it. Agreed?
Okay.
Okay, you
Yes.
want 4 from this expression, you cannot get it. But you can get 3.9, you can get 4.1, 3.99, 4.01, 4.001, whatever.
Okay.
Okay, you're approaching that number 4, but you are not exactly touching that number 4.
Okay.
Okay, now the concept of limit is, the entire concept of limit is what number you are approaching. You are touching or not, it's different. But the concept of limit is whether you are approaching or not.
Okay.
That is a concept. So in this case, limit extends to 2. That is 4. You are touching also. You are touching 4 also. In this case, limit extends to 2 is also 4. But you are not touching. Limit is not about whether you are touching or not. Limit is more about what you are
Approximately.
approaching. Okay? Limit is more about what you are approaching.
Yes.
Okay. So in this case, what is happening? This is when you are doing, it becomes 0 by 0. Right? When x equals to 2, it becomes 0 by 0.
Yes.
Right. Or in some cases, you will get only 0 in the denominator. In some cases, you will get 0 by 0 in the denominator, whatever. But, but is there something it is approaching is the important question. Is
Mm.
it approaching some number is the important question. That's all limits are about. Okay.
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 Yes.
Now we have different ways of this evaluating these limits, etc. Okay. Now, so we discussed about this now, no? This line versus this line. Okay. There is this point that is missing. We call this as a hole. Okay.
Okay.
Okay. So there is this point that is missing. Now, when you try to calculate, you will get every number except 2 in this case. Okay, ma?
Okay, sir.
You will get every number except this 2, but this one you will get exactly 2. Okay. So that's why we say the limit is tending to 2. Okay. Okay. In some cases, you might exactly get that number. In some cases, you might not touch the number. We are not talking about touching the number. We are just talking about approaching the number. Okay. Okay. Now, if you look at this function, okay, if you look at this, so in this case, see, if you are approaching 0, you are not touching any number. So
Oh,
that means at 0, the limit doesn't exist.
okay.
Okay, because if you are approaching from the right hand side, you are getting plus infinity. If you are approaching from the left hand side, you are getting minus infinity. That means the limit does not exist. Everywhere else, the limit exists because if you are approaching, let's say 1,
Huh.
you are approaching from the left side and right side, you are approaching the same value. That means limit exists. See here, limit exists everywhere except it this thing. Okay,
1.
1 second.
Huh.
అమ్మా చెప్పు. హలో, అమ్మా చెప్పమ్మా. హలో 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 చెప్పమ్మా. హలో, నీ వాయిస్ బ్రేక్ అయిపోతుంది. ఈ రోజు నువ్వు కెమిస్ట్రీ ఎగ్జామ్ ఉంది, అది చదువుకుంటున్నావు కదా. ఓకే, అది కానిచ్చేసి అయితే. ఏదమ్మా ఈవినింగ్? నీ ఎగ్జామ్ ఎప్పుడు అవుద్ది? 6కి అయిపోద్దా? 6:30 అలా వచ్చేసి అయితే అక్కడికి. హలో, ఓకేనమ్మా? ఓకే అమ్మా. Okay, so see for example here at this point we cannot clearly say, because once see, limit is when you are saying that limit is some number. Okay,
Okay.
then you should be able to show that whether you approach from the left, you approach from the right, you are getting as close to the number as possible as you want to that number. Okay, so here you cannot claim what is that number. At this point, if you claim, say for example, okay, at x equals to 2, the limit is 1. Let's say you claim. Then that is fine. When you want, when you get closer to x is getting closer to 2, the y is always 1. Agreed?
Yes, sir.
Okay. But here, when x equals to 0, if you claim the limit is 0.5, okay?
Okay.
Let's say, for example, let's say 0.5. Then let's say you want to achieve some number like 0.4. There is no way you can achieve that 0.4, right?
Yes,
Either
sir.
you will achieve 0 or you will achieve 1. There is no way you can get close to 0.5. Agreed?
Yes,
The
sir.
point I am trying to say. Okay.
So there is no point which is defined where limit doesn't exist.
Limit should, so when you claim a limit,
Okay.
okay, you should get very close to that number, as close as you want. So when you claim that a limit is 0.5, then if I say, okay, give me an x where the value is between plus or minus 0.5 plus or minus 0.01. Okay, but here you cannot do. In this case, you can do. Understood?
Okay.
Okay, or otherwise I'll give better examples. Okay, that is epsilon delta definition. I will show you with a better example. Wait, here that would be there. Okay, see here. Okay, this function. This is a function. Okay, we are talking about limit at 4. Okay, what is the limit at 4? What is the value at 4? 2 4s 8 minus 1 7. Okay, agreed.
Yes, sir.
Okay, now what I am saying is you define some values of x such that your values of y should lie between plus or minus 2 of 7. Okay,
Okay, sir.
you got my question? Your y value should lie between plus or minus 2 of 7. Then tell me what values of x that you have. Okay, then you can say x is plus or minus 1. Okay,
Okay.
okay, if you want y plus or minus 2, then okay, take x plus or minus 1.
Okay.
Agreed. Okay, y plus or minus 2. Then, but if I say, okay, y plus or minus 1, then you would say something like x plus or minus half.
Hmm.
Okay, if I say y plus or minus 0.1, then you will say x plus or minus 0.05 or whatsoever, something.
Yes.
Understood? Okay, this is what you will say, right? So,
Yes,
for
sir.
example, uh, y, you are claiming the limit is L. Then I say L plus or minus 1 by 10. Okay, then you say, okay, fine, x plus or minus something. Okay, you take this range. So then I'll say, okay, y plus or minus what is this limit plus or minus 1 by 100. Then also you'll be able to say, okay, you take x's in this range, then you will be able to get y's in this range. Okay?
Okay.
Okay, x is in this range around x naught. Okay,
Mm.
around x naught. So whatever, if I want y's in this range around x naught, around L, then you will say, okay, take x's in this range around x naught. Okay?
Okay.
Okay. Now, in the earlier case, this is plainly not possible. Understood? Why? What I'm trying to say? Why is it
Yes.
not possible?
Because when you select a certain range, you
See,
won't
in
get
the
the actual answer. You'll get something approximate to it.
in this case, okay, in this case, at this point, if I say, okay, your y has to be within 3 plus or minus 1. Okay,
Okay.
then you say x should be 1 plus or minus zero point 0.1 or zero point 0.5, whatever.
Yes,
If I
sir.
say your y should be 3 plus or minus zero point 0.1, then you will say your x should be between 0.001 plus or minus 0.001 or something. Okay?
Okay.
Okay, because you are claiming the limit is 3. Now, at 0, let's shift the focus at 0. At 0, what limit can you claim? Let's say you claim the limit as, let's say, 4 or 100 or whatsoever. Okay?
Okay.
And let's say you claim the limit again as 3 only.
Huh.
Okay. You claim the limit as 3, then I ask, okay, you are claiming the limit as 3. Now tell me between what range should I move from left and right of 0 so that your y is in the range of 3 plus or minus 2. Understood?
Okay.
So your y, if you are first of all you are claiming that limit is at 0, then I am claiming at limit at 0 is 3. Then I am saying, okay, fine. I want to be within the range of 3 plus or minus 2. That is plus 5 to plus 1. Okay? Tell me the range of x. But there is no range of x, right?
Yes, sir.
There is no range of x where the function is approaching 3. Basically, in normal terms, what that means is, well, if the function is approaching 3, then limit exists.
Okay.
Here it is not approaching 3, no. If it is continuous like this, if it is approaching from both sides, then you can actually say, okay, x, it can be between these two values. Right? If it is not approaching 3, then obviously you cannot say. Right?
Yes.
In normal terms, this we talk we in plain English. This is what we say. As long as the function, the graph is actually approaching some number from both sides, that means the limit exists. Because whichever number around that number, okay, whichever y around this 3 you want, there will be some x around this x naught. Okay, if
Understood.
it is approaching, but if it is not approaching like this, one is approaching one side, another is approaching one side, so then actually your y is not revolving around this number, right?
Yes, sir.
Y is not revolving around this number because one is approaching one number, another is approaching another number.
Mhm.
Then y is not revolving around this. If both are approaching this number, then y is revolving around this. Okay.
Okay, sir.
Okay, so now in these cases limits do not exist. Okay.
Okay.
Okay, but in these cases limit exists. Okay.
Understood.
Okay, now look at this function. Okay, clearly when x equals to 1, this is 0.
Yes, sir.
Okay, when x equals to 1, and numerator also it is 0.
Yes,
Okay,
sir.
we don't know what exactly is this. Okay, but like in the earlier case, if you take the common factors and if you cancel out the common factors, this is x plus 2 by 2. Okay,
Yes.
the graph of x plus 2 by, sorry, x plus 2 by x is this. Okay, so this one is not defined as x. This graph is exactly equal to this, except at the point this one, 1 comma 3, right?
Yes.
Okay, so then limit extends to 1, we call it as 3. Okay, so basically what we have done, we have transformed this function, we have found a revised function, which is equal to this function, which is defined at x equals to 1.
Yes, sir.
Agreed? Which is defined at x equals to 1 so as to find what is the limit at 1.
Why?
Okay, so what did we do here? We did not do much. Wherever we removed that just x minus 1 as a factor. Okay, so this is becoming 0. This is becoming 0 at x equal to 1. That means there is an x minus 1 factor in this, right? This
Yes,
is
sir.
becoming 0 at x equals to 1. That means there is some x minus 1 factor here. We just removed that factor.
Okay.
Okay, so if you remove that factor, because this is the only thing that is making it 0 at x equals to 1. So now we are sure. We are sure at x equals to 1.1 or 1.01, there is some value. We can easily calculate. Here also we are sure. This is working everywhere except at x equals to 1. 1.1 it is working, 0.99 it is working, etc. etc. Right? So,
Yes.
so the very basic of this is basic way of calculating limits is you cancel out all the factors. Okay,
Okay.
all the factors where the numerator and becoming are becoming zero together. Okay,
Okay.
so that is the basic, very basic thing about limits. So here, look at here. Here, it is becoming zero.
Hmm.
Okay, when x equals to zero, it is becoming zero. But if
Yes.
you try to plot a graph, right? Mostly this function, if you put it in a this one GeoGebra or something, if you try to plot the graph, mostly this will be continuous except at this point x, if there is a limit. Okay,
Okay.
around x it should behave the same thing. Okay, in this case, what you are doing, we are trying to find the replica of this function or some other function which behaves like this and probably which is defined at x equals to 0 also. Okay,
o-
we rationalized this, we did some simplification and we reached here. Okay,
Okay.
this function is exactly equal to this function except at x equals to 0. Right?
Yes, sir.
Okay. Now, this one is simplified. Now, if you substitute x equals to 0, you are getting 0.05. Understood?
Yes, sir.
Okay. So that is the limit. Say, for example, when it is approaching this one, you are getting 0.05. Okay. If you take basically any limit, if you have a scientific calculator, no, you can
Yes.
easily calculate. Instead of x equals to 0, you substitute some number which is close to 0. Okay. Then what you will get? You will get some value of y, which
Yes,
is
sir.
actually close to your limit value.
Hmm.
Understood?
Yes, sir.
When if you have scientific calculator, you don't need to do any manipulation. You can directly input this values x equal to 0.01001, etc., etc., to get your limit that you are looking for. Okay, ma?
Yes, sir.
Okay. So now, okay, you know the sandwich theorem. Okay. So now there is some function. Okay,
Okay.
there is this function h. Okay, this h is behaving like this. See, this h need not be defined at c. Okay,
Hmm.
what we are
Yes.
just saying, h is approaching this L at C. We are not
Okay.
saying h is defined at C. Similarly, we are not saying G is defined at C. We are just saying G can be defined, but we are definitely saying G is approaching L at C. Agreed?
Yes, sir.
There's a function we don't know whether h of C is L, but we know limit x tends to C for h is actually L. Agreed?
Yes, sir.
So basically, what we are trying to say, h is approaching L, G is also approaching L. Okay. Now, if we put some function which always lies between h and G, then obviously this f also should approach L at C. That is the sandwich theorem. Basically, we are sandwiching this function between these two functions. Understood?
Yes, sir.
Quite simplistic. At least it is very rational, right? If
Yes, sir.
there is a function and there is a function, both functions are approaching some number at this value of x. Obviously, the middle one should also approach that number only. Agreed?
Yes.
Okay, this is sandwich function. Just keep it aside. Where we live, we'll get some use cases later. Okay. Now you know sine theta by theta equals to 1, right?
Yes, sir.
Okay. So how did we get this? We'll shortly discuss that. Okay. Now, okay. First tell me what is the limit at x equals to 1? Is
At
there a
x
limit?
is 1, it is 1.
No, no, it is not 1. There is no limit. See,
Okay.
if you once you claim 1, it is not approaching 1, right? Left and right.
Huh. Yes, sir.
Okay, x equals to 1, there is no limit. X equals to 2,
There is a limit. 1.
what is that? That is 1. X equals to 3,
No limit again.
no limit again. The function is defined here. Okay,
Yes.
the function is defined, but doesn't matter. We are not talking about whether the function is defined or not. We are only talking about whether
The
the
limit.
function is approaching or not. Okay,
Yes.
here at minus 2, what is the limit?
No limit.
It is there, 0. Both sides it is approaching 0.
Okay. Okay. Then
Okay,
got it.
minus to both sides it is approaching 0. So the limit
Yes.
is
0.
minus 1 at x
No,
equals to
no.
Careful. Both sides it is approaching minus 1.
Okay, like that we need. Understood,
Understood.
sir.
Understood. If you are approaching minus from left side, you are approaching this number. Approaching minus from right side, you are approaching again the same number. Okay.
Yes, sir.
Okay. Then what about zero? If you are approaching zero from left and right. Okay. You are
Huh.
going along the graph. Which number you are approaching in terms of y?
-1 to 1.
So then what is that number? What is the limit? Is it minus 1? Is it 1? Is it 0?
0.
It is not. See, when you are approaching that number, it is not so there. It is not continuous. No. So there is a
Yes,
break
it's
here. So
changing.
it is. So if when you claim it is 0, then okay. Now tell me x where the my function is lying between plus or minus zero point 0.5. It is not there, right?
Not there.
It is not there. You have to tell some x around 0 where the function is between plus or minus zero point 0.5. It is not there, right? The
Yes, sir.
function is at minus 1, the function is at 1. Okay. So basically, limit exists only when the function is continuous smooth except at that particular point, probably.
Okay.
Understood. So now tell again at x equals to minus 2, what is the limit?
1.
Why 1?
-1.
X equals to minus 2.
Okay.
X equals to minus 2. What is the limit? We are approaching x from left hand side.
Left
Okay.
hand side.
Okay. When we approach this function from let's say minus 2.5, minus 2.1, minus 2, whatever. Okay. What is the value of y that you are approaching? What is minus 2.1? F of minus 2.1?
F of -2.1 is equal to -2.
No, it's not minus 2. This is see. It is some 0 point something, minus 0 point something. F of minus 2.1. That is this
Okay.
point, no?
Yes, sir.
What is that value?
0.
0, slightly lesser than 0, no?
Yes, sir.
F of minus 2.1. F of minus 2.01, that is also slightly lesser than
Lesser
0, right?
than 0. Yes, sir.
Okay. Now f of minus 1.9. What is that value?
Again, slightly lesser than 0.
F of minus 1.99. What is that value?
-2.
It is
Like,
not minus 2. F of minus 1.99. That is this one, no?
yes.
Okay. What is that value? Value of y.
0 again.
It
Like,
is approaching 0. Okay.
yes.
You are getting my point. Okay.
Yes, sir.
Okay. So that's why whether you are approaching this graph from the left, you are approaching this graph from the right, you are still approaching this value which is 0. Understood?
Okay.
Okay. Now here you are approaching from the left. Okay. F of minus zero point 0.5. What is that value?
Almost equal to -1.
It is minus 1 only. This is flat, no? Minus
Huh.
zero point 0.5 it is minus 1. Minus zero point 0.1 it is minus 1. Okay. Left side you are approaching minus 1. Okay. Similarly, if you are approaching 0 from the right side, where are you approaching?
To 1.
To 1. Both are not same, no?
Yes, sir.
Your left approach and right approach should give the same result. Then limit exists. Okay?
Okay.
In this case, at 2, what is your left approach? If you are approaching from the left, where are you heading to in terms of y?
Almost equal to 1.
Almost equal to 1. You are approaching 1. If you are approaching x from the right, y, where are you approaching?
Again at 1.
So
Like
that's why the
1.
limit is 1. In this case, if you are approaching x from, if you are approaching 1 from left, where are you approaching?
At 1.
You are approaching 1. If you are approaching 1 from right, where are you approaching?
At 1.
Why 1? No. Don't confuse. This value of y is 0, no?
Huh. Yes, sir.
If you are approaching from the right, you are approaching this value, right?
Yes, sir.
This value is 0, right?
0.
0. Here, this value is 1. And we are
1.
talking about y. We are
Okay.
approaching 1 y. We are approaching 0 y. Both are not same.
So limit does not exist.
Limit does not exist. What about this one? Approaching 3 from left.
Then y will be at 0.
0. Very good. If you are approaching 3 from right.
At 1.
Why 1? 3 from right. 3 from right. Which one
Again
we are
0 only.
again 0, no? 3 from
Okay.
right, 3 from left. Again, both are zeros. We are approaching zeros. Right. So that's where limit exists.
Okay.
Understood? Your left approach and right approach should be to the same number. Okay.
Okay.
In this case, at 0. What is your left approach? We are talking about this number. At x equals to 0. What is your left approach and what is your right hand side? Where are you approaching? Y
It's
in
1.
1 or minus 1 or 0? Be careful. Y axis is this.
Okay.
Okay. Which y you are approaching when x is approaching towards 0 from left hand side?
From right side.
From left side.
Left side 0.
Left side you are approaching 1, then obviously you are approaching 0. Y is coming closer to 0, right?
Yes, sir.
Okay. What about you are approaching from the right side?
Again 0.
Again 0. So the limit at x equals to 0 is
Exists.
0. That is the value is 0. Okay.
Yeah.
Okay, it exists, and what is that value? When it exists, obviously that means there is a value. What is that
Yes.
value? It is 0.
Yeah.
Okay. Okay. Now limit x tends to 1. You tell me this. Limit x tends to 1. X is approaching 1 from the left hand side and the right hand side. What exactly is y approaching?
From left hand side, it is
Ah,
0 only.
wait. Why it is 0? Left hand side, it is you are approaching 1. Why are you approaching 0? You are approaching minus 1, no?
Okay. Yes, sir.
Okay, you are approaching minus 1. Be careful. Left hand side, you are going along the graph. Where will you reach? You will
Minus
reach
1.
minus 1. Right hand side, you are going along the graph. Where will you reach?
1.
Okay, so that means
Two
both the
different
destinations are
values,
different.
so limit does not exist.
Limit exactly. Okay. See here, left hand side, you are approaching, you are reaching 1. Right hand side, you are approaching, you are reaching 0.
0.
Both are not same. Here, left
Yes.
hand side, you are approaching 1. Right also, you are approaching 1. Okay.
Okay.
Now tell me, at 0 in this graph.
Uh, to 0, from left side, left hand side, it will be 0.
Right hand side.
Right hand side, it will be 0 itself.
Very good. So that's where the limit exists. What about
Okay.
this point at x equals to 1?
From left hand side, it is reaching minus 2.
Very good.
And from right hand side, it is reaching 1.
Wait. Don't get confused. This point is what?
0, 0.
0, not 1. Okay?
Yes,
Don't get confused with this one. It is 0.
0.
Left hand
So
side is
both are
minus.
not same, so limit does not
Very
exist.
good. At x equals to 2?
It is approaching at 1 and then 0.
Wait. Careful. Left hand side, what is the approach? Where is it approaching?
Left hand side 0.
Why 0? This is the graph, no? This
Okay,
is the
for
graph.
left hand side.
This is the graph. Okay. This is only for this point.
Okay,
Okay, left hand side is don't
1.
that's all. Limit is not about what is the value of the function at that point. Limit is all about what is the
Approaching.
function approaching. Okay?
So from
Left hand
left
side.
hand side it is 1
Very good.
and from right hand side it is 0.
Right hand, why is it 0?
No sir, both at 1 only.
Both at 1. Okay? Right
Ah,
hand side, if you approach 2, you will reach 1. Okay?
yes sir,
Left hand side, if you approach 2, you will reach 1. So
1.
both are approaching 1. Okay?
Okay,
Understood? No?
yes sir.
Okay. So then, okay. So the limits, just try to recollect all of this. Okay, it's graphically it is about approaching certain number. Okay,
Okay sir.
okay, it is about graphically approaching certain number. So now, so for example, in this
Okay,
case, left hand side, right hand side, you will approach the same number. You can directly substitute. Okay, in some cases, you can directly substitute. Okay. In some
yes sir.
cases, you have to rationalize numerators and denominators. Okay. So this is graphically, but in a lot of cases, we can directly do algebraic manipulation and directly go ahead and find the limit. Okay.
Okay,
Okay. Because most of the functions that we deal are continuous functions or smooth functions. So that's why if you directly substitute also, you'll be able to get. Okay? Or otherwise,
Okay.
we'll remove some common factors and find out what exactly is the limit. We'll find what is the other function which behaves like this. Okay? Which
Okay.
is defined at that particular value and we get to the limit. Okay?
Yes, sir.
Okay, cool. So then remaining we'll see tomorrow. Okay.
Okay.
Okay, just what you do, just look at some basic problems in limits. Okay,
Okay, sir.
you might not be able to get all the problems, that is fine. Just look at some problems, what exactly they are doing. How, so mostly what you will do, you will see different ways of cancelling numerators and denominators, taking out factors or whatsoever. So what is the
Okay.
goal? The goal is if you directly substitute, you will get 0 by 0 mostly. Okay,
Okay.
so they will do something to avoid that 0 by 0.
0 by
Mostly,
0.
mostly they will rationalize numerators, denominators, or divide numerator and denominator by something, something, etc., etc. Okay,
Okay.
just see what exactly are they are trying to see. If you don't get also, that is fine. Okay, just look at what they are trying to do.
Okay.
Okay, remaining we'll see tomorrow. Ma.
Okay, sir.
Okay, ma. Take care. Bye bye.
Bye, sir. Thank you.